Hi, this video is going to serve us as an introduction to the topic of software package management. So I'm going to give you an idea of what software package managers are good for, why do we need them even to start off with. So to do so, I'm going to just go back a little bit in time and discuss a little bit how things are done without a software package manager, and try to contrast that to the way things are done with Linux. And more specifically, we'll discuss about the specific Linux distribution, obviously, that we are working with this semester. So let's start with the prehistoric times before software. We're going to use this abbreviation a lot probably. So software package manager. So what did we have before software package manager? The ID is still very much in use today. If you have been using a Windows workstation, what I'm going to discuss now is going to sound very familiar. What do you need to do when you want to install a piece of software on your workstation? Well, the first step, and we should really number it 0, because sometimes it's something that is already taken care of for you, sometimes it involves more or less work. So let's call it step 0, okay? Step 0 is really about locating the software, and I'm going to say installer. Okay, so you want to install, I don't know, a web browser like Firefox. You need to find on the web where to download the Firefox. You need to go to their download page. You need to find the installer that is appropriate for your operating system, for your version of the operating system, for whether it's 32-bit, 64-bit, etc. So once you do that, you find generally a binary file, okay, an executable file, which is the software installer. Sometimes you do not have a binary available for your workstation, so you can have access to the source, and then you will have to download the source, and then it's a different installation process. Okay, it's a little bit more involved. You need to make sure that you have all the development tools required to compile the source. There can be libraries, there can be specific compilers, maybe even specific version of compilers. That happens, and you are going to pretty much compile the program yourself, and at the end you will have either an installer or the executable itself for the program that you are trying to install. Okay, I'm not going to talk much in this video about this aspect of things. I'm going to focus more on the common case, which is, I want to install a software. I have an installer available somewhere that has been already prepared by somebody. So the first step is really locating that software, and it can be problematic in itself. Okay, you have all experienced this googling of software that you want to install on your Windows machine, and then you get like less than reputable sources to download it, or you get sources that that are different from the official website of the software. So maybe there are a few versions late, yet they are lagging a few versions compared to the latest release, or maybe they have downright viruses or other sort of malware, in the installer that you would not find if you were downloaded from the official site for that software. So this in itself, I mean, even though it looks like a trivial step, it can be a hassle to a certain extent. What do you do next? Well, the next thing is running the installer. Right? So this is the installation process as everybody refers to. So you are just clicking that executable if you're on Windows. Okay, it's going to generally unzip some information that is part of the installer onto your system, install it at the correct location, maybe download some updates in the process. And that brings us to the next point. It's not necessarily the next task, but without any sort of software package manager, you have to also handle more than just the installation by yourself. You have to handle things like bug fixes, okay, security patches, all of those things. Every time there is a bug fix, every time there is a new release, and we're going to talk about 4 features. Okay, so every time there are new features implemented that are available in the latest release, every time there is a bug fix, every time there is a security patch, you need to pretty much figure this out all by yourself and install that all by yourself. So all of this is part of updates. Okay, so it's not part of the initial installation process per se, even though sometimes it's done right after the initial installation process. It's more part of the routine maintenance of the different software you have installed on your machine. Um, One of the things that is important about those updates is how do you track them? Tracking updates. There are different solutions. Again, we are talking about no software package manager available, right? So generally that means you have to do it by hand. What does that mean to do it by hand? Well, it depends. In the worst case, you have to check official website regularly. That's really the I don't think many people still do it this way, but there are still some examples out there. So that's the worst case scenario, because you are totally on your own to actively go to a specific website and check it on a regular basis for updates. If you do not do so for a month or two because you are busy doing other things, obviously, what are you going to miss? Are you going to miss maybe a new release for features? That's not a big deal. As long as you don't feel a need for the features, one could argue that you're not missing anything. Are you going to miss some bug fixes? That might be actually more bothersome. But if you are missing security patches, that can be downright unacceptable. Let's take the example of I don't know, you're running some web server on your workstation, just a small personal web page. Missing actually a security patch release for that kind of software that is open to the internet, that has networking ports open to the internet, that is publicly accessible, can actually endanger the whole setup of your machine. And beyond your machine, once people are in this particular machine in your network, they might be able to use it as a jump start, to go to other workstation and servers that you have on your network. So this is where it becomes, how to say, past awkward and rather unacceptable to have to track updates totally by hand. So thankfully there are alternatives, okay, even in the absence of some package manager. But as we implement those alternatives, we are progressively getting to the idea of having a package manager. But it's just taking us time, okay? So let's see what those alternatives are. We are going to, let me increase a little the font here. We're going to consider some alternative to this by hand approach. I don't know if we should even call it an approach. Okay, so what happens on a Windows system generally? Because we are, like I said, for many applications we are past this level. Some of them are still like that, but thankfully, you don't have to deal with that kind of stuff too often. Well, generally, the responsibility to manage the software installation and more importantly the software update is delegated to each program, each app, okay, each application. So each program, each application is responsible for tracking updates, okay, and that's easy enough. There are different choices here again. Okay, we have like a lot of options that are unfolding in front of us. The first option is probably the easiest, is when you start the app, check for updates. It's not a bad policy. It's just a little awkward, a little cumbersome. Every single time you start your app, you're going to devote whatever amount of resources is necessary to go and check for updates, right? It would be much better if actually the server was capable to push those notifications for updates directly to your machine. Well, okay. The problem here is really if you are talking about an app that you start once every month and let run in the background for an entire month, it's not a big bother. But while you are running the app, you would still want to benefit from updates, right? So it's not bothersome because it doesn't take much resource, but you lose the benefit of having frequent updates. The other end of the spectrum, the other extreme case, is an app that you have to start, I don't know, every 5 minutes. Imagine a little command line tool or something like that. So every 5 minutes you're going to spend a few seconds, maybe a minute or so trying to contact a server. Maybe it's going to time out, blah blah blah. Okay, so this is not the ideal situation. So that's our first solution. When we start the app, you check for updates. Then you have another solution which is used quite frequently actually. Regularly check. I cannot type today, sorry about that. Check for updates. So what does it mean, regularly check for updates? Well, that's a direct answer to the fact that it's quite stupid to check for updates probably 25 times a day, is just because you have been starting this application 25 times today. So the idea here is that the application will check for updates when it's started, but it will do so on a regular interval. That is often something that you can configure. So you can decide to check for updates every time you start, which would put us back in the first alternative, or you can choose to check for updates every day, once per day maximum, or every week, or every month, or whatever you can imagine there. So again, same benefits, it's a trade-off, same benefits and disadvantages. Yes, it's less bothersome. You are not prompted all the time by your system saying, I'm checking for updates right now, come back in 5-10 seconds. So it's more practical from the user perspective. Is it really acceptable for software that is actually at risk and should benefit for security patches immediately? Not really. That's still leaving a window of opportunity for zero-day exploits and things of that nature, and this is not a good thing. Okay, so the next solution is to have what I will call server pushed updates. So that means that somehow your system is not going to initialize the communication with the server. And by server I mean the software that's running on the official website of your specific app, and that's going to notify you of updates. But we allow that server to push down updates to us. Well, that's again arguable. It depends on how it's implemented. Most of the time, this is actually a misnomer, because the server pushed update are still communicated to your software after your software initialized a communication with the update server. The alternative would be to have your software listen to a port, a networking port, and have the update server aware of how to reach everybody who has deployed that software, and that's somewhat unrealistic. Okay, your IP address is going to change constantly, so that would involve, a sort of a dynamic DNS scheme where your app is going to inform that remote app server of where you are at on the internet. What is your current IP address? Open a port, thus potentially opening a security port. This is really messy. There's no real fully satisfying ways you can see to do this kind of stuff. It's still better than checking by hand. Don't get me wrong. And if you're not convinced of that, think about instead of checking the official website regularly, think of alternative where you have to wait for a message on a mailing list or something like that. That would be even worse. I mean, there are like a lot of ways we can imagine tracking updates by hand, and most of them are way less practical and secure than any of those options actually. So it's a progress. It's a progress in the right direction. If you think a little about how this scales up, you might want to again, look at this a little bit critically. These kind of solutions do not scale up very well. Why? Because the responsibility of updating has been delegated to each application. So in the case where you start an application that checks for updates, either if it does it every time regularly or just communicate a quick message to an update server to give its IP, for example, this can scale up relatively reasonably. What doesn't scale up at all is the idea of an update monitor, and I should say app specific update monitor. So what do I mean by app specific update monitor? The idea of update monitor is used in the Windows world. Not only in the Windows world, but this is where it has probably started. If you look at your tray, your icon tray, you are going to see sometime that some software is constantly running in the background. I think that as of the recording of this video, Chrome is doing that right now. Google Chrome, the Google Chrome web browser. So what does that mean? That means that having this kind of little background process running on behalf of Google Chrome all the time allows for very nifty things. For example, as soon as an update is released, This little background process can check every I would hope not every minute, but every hour, every 6 hours, every whatever is your interval, can check automatically to see if there is an update. And then you would be informed relatively fast of whether there is an update. The problem here lies in scalability. Let's say that you have, I don't know, 200 pieces of software installed on your workstation, and this is something that's not unrealistic by any stretch of the imagination. So can you imagine having 200 app-specific update monitor? We're going to abbreviate that, okay? Can you imagine having 200 of those app-specific update monitor, each providing you a service that's valuable, but each actually cluttering your icon tray, each actually using CPU cycle at regular intervals? Maybe you would have to go and parameter those intervals, but there is no centralized way to do it. So you would find yourself going through 200 pieces of software to just tell them, you know, I want you to update every hour, I want you to update every month, I want you to update every day, whatever is reasonable. And all those software would run in the background, and depending on the frequency with which they are activity, depending on how bloated they are, they might end up consuming a significant maybe amount of resources that would be much better devoted by your workstation to do actually other things that the users are trying to get done, right? So this is the Achilles heel here of this system. We can do things that are very neat with app-specific update monitors. But they come at a cost, and the cost is not necessarily acceptable in terms of performance, okay? And also in terms of burden to administrate all those independent, you know, app-specific monitors. So all of this led to an ID. An ID that was actually, as far as I can tell, that started in the Linux community. That started with different Linux distributions such as Debian, Red Hat, which are probably the two most known distribution for their package management systems. So the ID is that of, it's a twofold ID. The first ID is that of having a software package manager, a single software package manager on your system. And then the ID is also to have, in addition to that software package manager, repositories, software repositories, okay? So let's talk a little bit about this. Software package manager, having one single software package manager. This is no longer a new ID. It was implemented decades ago in the Linux community, but if you look at any modern system now, everybody else has been catching up with what was done in the Linux community, and I would say has been also adapting the idea of software repository, which was born pretty much in the open source movement, where a software repository contained all the code for an application, allowed you to download it freely, and so on and so forth. Okay, but this idea was clearly, you know, meant for open source software primarily, and this idea has been adapted to other environment where we do not necessarily have access to 100% open source software. So the example that might come to mind are the Google Play App Store, any sort of App Store, any sort of marketplace. Okay, same thing with the Amazon Kindle. Kindle has its own marketplace. Then we can talk about the Microsoft App Store, Microsoft App Store, the Mac. I don't remember how they call it. Macintosh has its own App Store. Microsoft has its own App Store for Windows. So nowadays, every operating system, whether it's Android, iOS, Mac OS, or Windows, has some sort of, they call it App Store. They call it marketplaces, and this pretty much fulfill some of the ideas of having a software package manager and a software repository. If you go on your Windows system, you can also see that there is a central way to install and remove pieces of software right on your workstation. However, if you have ever used that system, you know that it just invokes an individual installer. Okay, and except for Microsoft product, it rarely manages, tracking updates and things of that nature. Most of the time, if you have something like Adobe Suite installed on your Windows workstation, well, Adobe will notify you when an update is available. Firefox will do the same. Google Chrome will do the same. There is no unified, one place to rule them all, if you want to look at it this way, system in a Windows workstation to manage all the software updates that you might have to deploy. So the idea of a software package manager, a single software package manager, is that the single piece of software, the single program is going to run on your machine in the background and is going to process updates for all of the software that is actually installed on your machine. Now let's talk about software repositories. Okay, we talked about already the equivalent in Google Play, Kindle, Microsoft, etc. So actually, I should cut and paste this and put it there. So these are the equivalent of software repository, and the equivalent of software package manager would be the software used to browse those app stores. Okay, including the Microsoft, software manager tab in the control panel. Now, back to the software repositories. The ID for Linux, the original ID for software repositories, was to make accessible not only installers but also the source code, because we are talking in this context about open source software, right? So the idea is that you are going to have official software repositories on which you are going to store the source, on which you are going to store the binaries sometime for all the applications that are available for a given platform. And in the case of app stores, you know that you can have devices that have both access to Google Play and the Kindle App Store. You can manage to have like different app stores available right to your device. Generally, these are mobile devices. Well, the same thing is true in the Linux world. You can have access to several repositories. There are two different type of repositories. The repositories that are just mirrors of one another. So for example, when you install a default Ubuntu install, you are going to have already the package manager pre-configured to access a few different mirrors, a few different websites. Why? Because if one is down, if one of the repositories is down, you can switch automatically to the other. And sometimes there are also optimization whereby you try to figure out which mirror is actually the fastest for you to download from. So when you push like big updates on your system, this might actually be a neat feature. So we have different repositories, okay? So I should write this down, different repositories everywhere. In the case of Linux, we can distinguish between mirrors and I would say, I don't know how to say that without repeating different repositories, but let's call them individual repositories. But this is the same idea, okay? The idea is that we have actually access to repositories that do not necessarily hold the same software. For example, I'm going to give you a name here so that you can look it up if you're curious. Ubuntu has official repositories for the for each Ubuntu distribution, and these repositories are mirrored. But in addition, there are things called personal. I think this is personal package. I don't remember what the A stands for. PPAs repositories that people can set up from the Ubuntu Launchpad, which is pretty much a Ubuntu centralized code hosting repository for projects in development. And from this PPA, people can actually set up packages, software packages, and by adding a specific PPA or several PPAs to the configuration of your software package manager, you can actually install packages from those specific PPAs. So it's a way to have a sort of miniature repository that a developer, for example, can set up for their own personal package for that one program that they're working on, and you can disseminate, the address for that PPA repository and have Ubuntu user add it relatively easily to their system so that they may now start installing your specific package, your specific software, your beta version of whatever software you're working on, as easily as they are installing anything else. Okay? So, the next thing I'm going to do is try to give you a big picture of how we interact with those software repositories and how we interact with those software package managers. So let's try to go for a little drawing. Sometimes a drawing is very good at summarizing situation. So the first thing that we have already detailed, that we have already discussed, is that when you implement a software package manager and you have access to repository, if this little pathetic drawing represents a workstation, we'll go for that with that, right? That means that on your workstation you have one program running, which is your software package manager. Okay, this is actually running on your workstation. Okay, so one program instead of a plethora of app updaters, pretty much. This program is going to be aware of, let's call it official repository number 1. Okay, so this would be in the case, let's use Ubuntu as an example, this would be in the case of Ubuntu publicly accessible server that would provide access to the installers for all the softwares that you can install on Ubuntu, the source actually. Okay, and all those things, installers and source, would be pretty much what is known as software packages. Okay, so we would have a specific format to put all the source, for example, and the scripts that are needed to build those source in a software package, or to put all the binaries, the library, and other information that we're going to talk about in a little bit, i.e. Dependencies that are needed for an installer. Okay, all of this would be neatly put in a format that is the software package format. So while we're talking about software package, let me just bring in some information here. What are the most common software package format in the Linux world? Well, the one that is associated with Debian distributions and distributions that are actually derived from Debian is a .deb package. So it's easy to remember. Okay, .deb correspond to any Debian or Debian-like distribution, and this includes, you know, Ubuntu, for example. Okay, and then the second main package format is .rpm, Red Hat Package Manager. So what is it associated with? Well, it's associated with Red Hat. Okay, so Red Hat, if you're talking about Red Hat Enterprise Linux, which is the professional version of Red Hat, or if you're talking about Fedora, which is pretty much the incubator for all innovation that end up being pushed onto the Red Hat Enterprise Linux version. But you might be also talking about things like CentOS. And CentOS is interesting. CentOS is actually Red Hat is the distribution of Linux, and everything is open source. So while the Red Hat company provides you an enterprise version of Red Hat, RHEL, and provide support for it, and provide, you know, services that allow your company to pretty much have everything taken care of by outsourcing the system administration and the support. They also provide the entire source for Red Hat Enterprise Linux open source. Same thing for Fedora. So the CentOS project is interesting because the CentOS project is a community enterprise operating system. That's what CentOS stands for. And pretty much what it boils down to is a group of volunteers that take regularly the sources released by Red Hat for Red Hat Enterprise Linux and repackage it so as to eliminate, you know, dependency on any hard-coded service, you know, support service, etc. that Red Hat offer, so that you may install actually the equivalent of Red Hat Enterprise Linux on your machine for free if you do not need or want to benefit from Red Hat support. So CentOS is pretty much a free version of Red Hat Enterprise Linux. It's in every point similar, but it doesn't provide you with the support that you would get if you actually purchased a Red Hat Enterprise Linux license from Red Hat and you purchase a service agreement. Okay, so these are probably the two software package format that are the most common in the Linux world. There are others, okay? For those of you who are curious, Slackware is another distribution. It's a very ancient distribution. It has a different way of managing packages. Gentoo as well has a different way of managing package. Gentoo focuses on the idea that you need to rebuild. When you install software, you should always rebuild it from source, compile it for your specific CPU, etc., in order to optimize performance. So that's the philosophy behind Gentoo. So different different Linux distribution will have different format, will have different package manager, different philosophy, different features. But deb and RPM are definitely the main one. And I would like to also mention that now that deb and RPM are found actually on other platforms. What does that mean? Well, for example, there have been ports of some software manager, some of the software manager package manager we're going to talk about have been ported to Mac OS X. Okay, some of them have been ported to Solaris. So that means that over operating system, there are open source teams that are adapting a specific software package format and a specific software package manager to other operating system to make them benefit from the facilities that are provided by a software package manager. So that kind of gives you an idea, even though we haven't yet, we haven't really touched yet at the technical details of how software package management works and why is it so essential, why is it such a great feature. But you can see, even if you don't see the benefit yet, you can see that there has been over the last decades a lot of energy invested in expanding what was originally developed in Linux to other platforms, okay, and extending it so that it can become a marketplace where you can buy application and so on and so forth. Okay, nobody is worrying about updating manually their software on an Android mobile phone, for example. This is done by your marketplace. So that kind of gives credit to the idea. If it was such a bad idea, not everybody would be adopting it like they are adopting it right now. So we went a little deep here. We talked about software packages. We talked about the names of different formats. I tried to give you an overview of the ecosystem that exists there, the different software packages that exist, and so on and so forth. Let's back a little bit here to the level of the repository. On this repository, we are storing pretty much the software packages for different versions of the same application. So you could have, for example, a software package for, let's say, I'm just taking an example, Firefox version 25.2. Okay, that would be a deb file, for example. Then you would have Firefox version 25.3. So you can store on those repository not only the latest version of each software package, but you can store pretty much all of their release, all of their history. And this is useful. Sometimes there are incompatibilities, we'll talk more about that, but sometimes there are incompatibilities, especially when you're talking about libraries. So let's say that I have here a GTK library, okay, version, I'm making up numbers here, so bear with me, version 5.23, okay. The GTK library is a graphic library that is used by applications that are providing a graphic user interface. So it allows you to build easily a graphic user interface for your application and run them on a Linux desktop. So here, let's say we have this version available on the repository, but we have also version 24, version 25, okay? If you are working on your workstation and you need to recompile a project, and this project for some reason used version 23, and there has been some improvements between quotes here between 23, 24, 25 that are not backward compatible, then you really want to be able to deploy on your system, this version of the library, so you can actually compile your program with that version of the library and then get it to work. Okay, so this is another interesting feature of repository. This is a feature that has not necessarily been adapted to most of the app stores, because in the case of app stores, the priority is to get users, to patch those security holes. As soon as the security hole is found and we have a release to take care of it, we want to deploy those security holes. We want also to deploy bug fixes so people stop complaining about the app that you wrote, you know. You want also to deploy new features, especially for those games that have new content, new seasonal content regularly. You want to be able to reach all your users and give them the Christmas, you know, extension pack for the game they are playing, for example. So the priorities for an app store and the priorities for a repository, a software, an open source software packages repository are not completely identical. There's a lot of overlap, there are a lot of features that are provided by both and in pretty much the same manner, but you can see that there are some features that are going to be specific to one word or the other, depending on what the customer base is, what the typical user is. So, enough about this official repository number 1. We have been discussing already that there would be mirrors of this official repository, so I'm going to call them official repository number 2, number 3. So some of them are going to be in the US, some of them are going to be in South America, some of them are going to be in Europe. The idea is that those software repositories are going to keep themselves in sync with one another. Okay, so no matter which software repository you use, you are going to have access to the same software packages. But the difference, like I already mentioned, is simply one of convenience. You want to have quicker access to some of the software packages depending on where you are located. Okay, what your internet connection is, where your internet connection is originating from. So we have those different official repositories, and then, like I said, we can have the PPA. So let's say that Alessio has, you know, PPA here. There we go. PPA for like a beta, I don't know, beta, super game, whatever project that you're working on, and the users can choose, in addition to those official repositories, to add those other repositories, and we are going to talk about how it's done later in another video. But they can add actually those repositories so that their software package manager becomes aware of them. And then suddenly that enables you, obviously, to download any software package that is stored in those repositories in addition to the official repository list of software packages. So that should give you a good overview here of both the variety of formats that exist for software package, the variety of repositories. What else can we say about repositories? Repositories are generally, this is actually an important remark, so let me add it here. Repositories are generally distribution specific. So I'm talking about these repositories here, the official repositories. Okay, official repositories 1, 2, and 3, for example. When I wrote this, I had in mind the Ubuntu distribution, and I told you that Ubuntu is a variant of Debian. Okay, I probably mentioned that several times by now. But even though it's a variant of Debian, one of the things that distinguishes Ubuntu from Debian is that Ubuntu has its own software packages that are hosted on its own software package repositories. And you have, similarly, you have Debian package repositories that are hosted maybe on the same server. The same server can host both Ubuntu and a Debian package repository, but they are different. Those packages are different. Okay, so that means that each distribution can choose to do things slightly differently. For example, between RPM and Debian distribution, the typical location where you would put your network configuration file can be different. The typical location where you would install specific software might be different. So all of those decisions are also part of what distinguishes one distribution to the other. So the way software installs, the way they manage software package, etc., can vary. Not only between two different formats, for example, the deb and the RPM format, because these are obviously different. There are tools to convert one into the other and things of that nature. I think the name of one of those tools is Aliens. I'm not sure. But the bottom line is that these are two different file formats pretty much to contain the information, to encapsulate the information about your package. Well, even if you're talking about the same package format, you can have different repositories for different distribution. Ubuntu and Debian, for example, both use the .deb package format. However, if you have a piece of software available on Ubuntu, it will have its own deb on Ubuntu repository and its own deb, potentially different, on Debian repositories. Okay, that's another thing that is important to explain. So as you see, we have a lot of options here, and this is generally what happened with open source. There are no boundaries to how much you can adapt and customize, and sometimes, I mean, 99% of the time, it's a great thing. Sometimes it leads to a sort of, Precambrian diversity explosion, and there are sometimes too many options to choose from. But in the long run, this is not a bad thing. So, for example, the fact that people that want to optimize the software they install on their machine have an opportunity to do so by adopting Gentoo is actually a good thing. Even though this is not the mainstream for Linux distribution, this is an option that exists, that is maintained by an enthusiast community of people that see the benefit to be able to do so. Okay, what else do we need to talk about? We've talked about package format, we've talked about repositories, but we haven't said much yet about the software package manager right here. So we have not said much about the tool that is supposed to allow us to do those things. So let me open a new tab here, and we're going to discuss a little bit about our, let me move this out of the way, software package, well, managers, plural. We're going to talk about different tools. So you expect probably by now that since I told you about all those possibilities for the package format, all those possibilities for the repositories format, based on what distribution you're using, that there are going to be like many different possibilities for the kind of software package manager that you are using. Okay, and this is true. Let's start a little with Ubuntu Linux. Okay, we are going to start with a specific example. How can you manage your software packages on Ubuntu Linux? Well, there is quite an ecosystem here, a plethora of different solutions. Let me start with, well, let's write here example. Okay, Ubuntu Linux, so something very specific. Just to write down here a few things we need to keep in mind. The format for the package is the .deb format, okay, the Debian format, and the repositories are Ubuntu, specific to Ubuntu, okay, and they are derived from Debian. Okay, so the official repositories. So just a reminder on what we already discussed about. Keep that in mind while we discuss about the tool, because the tools I'm going to discuss now are specific to that setup. And I'm going to start with what I consider the base tool pretty much. So I'm going to write it here at the bottom, dpkg. So dpkg is a Debian package manager pretty much. This is a program, this is a command line program that is capable to perform a few tasks, a few functions on a deb file. Okay, so just so that everything is clear, we are operating on a deb file. Okay, what are we capable to do on this deb file? Where we are capable to, there are a lot of things, so I'm not going to go through the man page, as I speak and enumerate all the options, but I want to give you an idea of what is the responsibility of dpkg and what kind of feature it provides for you, especially with respect to the other tools that we are going to discuss. Okay, that's the main thing. Alright, so we know we operate on deb files, so we would invoke dpkg from the command line and we would tell it to work on a specific deb file. So the assumption here is that the deb file has been already downloaded, is already there on your hard drive and is ready to be installed. Okay, and ready to be installed means a few things that pertain to the concept of dependencies that I'm going to talk about in a minute. So dpkg can install for you a software package that you already downloaded. It can obviously remove it. Okay, and there are two ways to remove something. Remove by default means you remove actually all the binary file, libraries, and things of that nature that you installed previously, okay, when you installed a piece of software. But that does not mean that you remove any configuration file. Okay, so I'm going to write here, keep config. Okay, why would you do that? Why would you remove a piece of software from your system but yet keep the configuration file? Well, this is something that is very common. Even on a Windows workstation, when you remove an application, most of the time the application silently removes itself from your system but does not mention that it's leaving behind all of your configuration file, your user files. Like for example, if you had an IDE, it's going to leave all the projects that you had on your machine. So sometimes it's a mistake to think that because you uninstall all the program on your workstation, that now your laptop is sanitized. You know, if you have like sensitive information on the laptop, like projects that you're working for a company, you just don't simply uninstall the IDE and then put the laptop in the nearest trash bin. That's not how it works. So the idea of keeping the configuration behind is that you may want to keep them if you are uninstalling your software and then reinstalling it either immediately or a little bit later on, and you don't want to have to go through the burden of reconfiguring your software. So it's kind of a nice feature if you are just trying to troubleshoot. But like I mentioned, if you really want to dispose of the complete information, then you need to use something else. And the something else is called purging. Okay, purging means you remove everything, including the configuration file. You get rid of everything. So there's more, and we will talk more about dpkg, but for now the idea I want to convey here is what kind of things can dpkg do for you, and what kind of things can't it do? Well, it cannot download. Okay, we assumed here that we had already the deb file, so that means that dpkg is completely oblivious to the idea of repository. dpkg was developed before the idea of repository started being implemented in the Linux community. So it was a nice way to download a software package by hand. So if we go back to our introduction, that means that we still had to locate where to download that package, but we didn't have to run the installer. Instead, we were using dpkg. Okay, so dpkg took the binary or source package and was capable to install it on our system, configure it to get started, and so on and so forth. Okay, so that's what we're talking about. However, that doesn't address any of the problem that we mentioned about updating. Okay, it doesn't address them at all. So we're not even saying we have one of those options here on the right. No, right now the only thing we could do to deploy a new version or a bug fix or a security patch would be to do it by hand. Okay, so we are talking about this. Check the official website, check a mailing list, download again your installer, and then run it. So that's what dpkg can do. dpkg can do running pretty much an installer. dpkg is the installer, the generic installer for any software package, but it cannot locate the software, it cannot download it. Alright, so let's move back to our tab here. So this is the reason I mentioned dpkg. From the sound of it, it sounds really obsolete. It sounds like it's deprecated technology because I already mentioned those repositories. But the great thing about command line tools, especially when command line tools follow the Unix and Linux philosophy, which is do one thing and do it well, the great thing about those little tools is that they are so specialized in one task that you can reuse them in other tools. You can develop, for example, a graphical user interface front end to dpkg. Okay, you could do that, and that means that you are going to have a team work only on developing widgets and buttons and graphical visualization of the list of packages installed on the system, and so on and so forth, but they are not going to worry about the core, the package management. So it's a very sound approach to implement all of your feature, like package management feature, in a little tool that you can test separately, and then implement a front end that's going to just make calls to the dpkg command. And that's actually what is done in the Linux environment for package management. We're going to talk about that in a few minutes. What else has been built on top of dpkg? Well, let's take a concrete example. dselect, and this is actually I would say obsolete technology. Okay, I don't think many people still use actually dselect, or there was an even more deprecated tool. I think that's tasksel. The idea of those tools was to allow you to select, instead of selecting, independent software package. For example, let's say that you want to run a LAMP server. Okay, so for those of you who have never heard that term, a LAMP server, that stands for Linux, Apache. So maybe you heard the name Apache web server. That's one of the most popular web server. So most of the website you navigate, or a significant portion of the website you navigate, are probably hosted on Apache. MySQL. And then people argue here, most people agree nowadays that this stands for PHP. Some people said it stood for Perl originally, or it can stand for both, it doesn't matter. So we're talking about an operating system, a web server software, a database server software, and a web-oriented programming language. Okay, so when you install those 4 components on your Linux machine, and you open up the port, to the port 80 to actually serve web page with Apache, we refer to this as a LAMP stack. You're going to hear the term LAMP stack, LAMP server. That's just an acronym to summarize that we are using those 4 technologies, 5 if you count over language like Perl, that are installed generally alongside. So why am I mentioning this? Well, because sometimes you don't want to necessarily say, I want to install Apache, and then I want to install those 2 libraries from Apache, and then MySQL and that extension from MySQL, and then I want to install PHP with those 3 libraries that I'm going to use to develop my web application. Sometimes what you want to say is, I want an entire LAMP server. I want something that is almost, turnkey. I want to install everything I need to implement a LAMP server. So notice how the focus is no longer on a specific, software package, a specific version of the software package. What we are saying is, we have a goal, we have a task. Okay, and I'm using the word task obviously here on purpose. Okay, we have a task to fulfill with this Linux machine, and we need all the software that is commonly part of implementing that service. So for example, you could use this tool to say, please install a LAMP server on my Linux workstation. And it's easier than to figure out, the different latest version of PHP, Apache, MySQL. Hopefully you already have Linux, okay? Otherwise you would not have access to dpkg, but it might be a pain to, to find those software packages, download them, and then install them individually, okay? Especially if there are some incompatibility with versions. So those tools originally were meant to be a front end for dpkg. Okay, so they would allow you to select a task, like I want the software I need to run a DNS server, a LAMP server, etc. So generally it's oriented to server tasks, but it's also tasks like, for example, I want a GNOME desktop, I want a KDE desktop. So those are also example of tasks, okay, because they require a lot of different package to be installed. And those tools would actually take care of downloading the packages and use dpkg to install those packages. There's no point in rewriting, software to actually install, remove, purge, or even, I forgot to mention it here, but search the available, not available, this is confusing. I should say search installed package. Like if you want the list of package that you have on your machine, you would be able to ask dpkg to find that for you. So search installed packages. All right, that's one of the main feature I forgot to mention here. So there's no point in re-implementing all those features. You simply write whatever code is necessary for those tools to go and fetch the package, all the packages that are associated to a task. You offer the user like a list of tasks, and you let them select, and then automatically you get the package. Then you have dpkg install them. Okay, so dselect is based pretty much on dpkg, and you can see how it's advantageous to be able to actually leverage all the work that has been done with dpkg. dpkg is not obsolete. You still need a tool to do those tasks, right? But what you need is other tools that are going to take care of other features that we talked about, like the repository management, like in this case, you know, like being able to select software package based on task, and so on and so forth. So you can build very easily when you follow that philosophy of each tool does one thing and does it well. Then you can use them as building block, if you will. Okay, so let's forget about those, at least, yeah, those technology, because we're not going to talk much more about them. But I would say this about dselect, is that dselect actually motivated people to start the APT project. Okay, APT as in apt-get. You probably saw already in this module practice assignment that we're going to talk about, you know, apt-get command and stuff like that. Well, the apt-get command, so let me write it here, apt-get command, the apt-cache command are just two examples of command line tools that belong to the apt suite of tools. So APT stands for Advanced Packaging Tool or Package Manager. It's pretty much a successor to dselect, so maybe I should not have erased it. Okay, let's put dselect here as pretty much what motivated the design of APT, and this over arrow here means that we are actually we are front-end. We are using dpkg. Okay, so motivated and use. APT is, if you will, the next generation of dselect. It goes a lot further. So we are going to have videos just on dpkg and APT, so I don't want to go into details, but I want to convey the big picture here. The big picture is that APT is aware of repositories. Okay, APT is aware of, is capable to therefore locate your package via a list of repositories that it is knowledgeable about. So official repositories, PPA repositories, and things of that nature. It's able to locate a package, it's able to download them. And it's capable to do something that we are going to talk a lot more about. It's capable to manage dependencies. So before, you know, we have a video just to discuss dependencies, let's give a quick overview, a quick definition here. What do I mean by dependencies? Well, I mean by dependencies that maybe Apache requires a certain library, okay, to work. Maybe it requires actually several libraries. And maybe they have to be even specific version. MySQL might need its own set of library, and maybe they have libraries that they both need, like this one here that I'm going to shade like this. Okay, so this is the concept of dependency. When you want to use Apache version, you know, Apache version x.y, a dependency would be a way to specify that in order for you to install and run Apache x.y, you need this library w.q, version w.q. Okay, so this would be a dependency. We're going to talk about that a lot more, but this is one of the, how to say, most important benefits of a package manager, being capable to not only install the specific software that you had in mind, but figure out everything that's needed on your machine to make that software work. And you can see how it's an evolution of the idea of task, right? In a way, in a certain way. But we go well beyond that. A task was pretty much an assortment of individual pieces of software that are necessary to perform a certain job, to offer a certain service on a server, or to offer a certain graphical user environment on your workstation, right? Well, the notion of dependency goes further than that. It says maybe there are other pieces of software that are needed, you know, to do a certain task. So we would call that a meta package, okay? A meta package would be, for example, the meta package LAMP server that specifies that we need PHP, Apache, and MySQL on that Linux machine to be able to implement a LAMP server. But beside this, we have also the concept of, in order to be able for Apache to work, Apache needs other piece of software. Generally, system-oriented pieces of software, but sometimes it's languages. Okay, for example, a piece of software, I'm not talking about Apache anymore here, but a piece of software here would require the library for a certain language to be installed, or would require, for example, the Java JRE Java runtime environment, okay, to be available. So to be able to run this software, you need to install the Java JRE that might require overthink. Okay, so that's a concept of dependency. All right, let me erase those scribbles here. What else do we have? Well, that's pretty much the core. I'm not going to go into more details since we are going to explore that in its own video. But that's the core of APT here. And then APT, what is interesting is that APT has been used actually by other pieces of software. The same way that APT relies, on dpkg, uses dpkg to install the software, so it locates them, downloads them, resolves dependency by downloading all the other packages that are necessary. So this is great because you don't have to worry about, if installing Apache requires 50 different packages, you didn't have to look by hand, to figure out which package and which version of each package are necessary. This is done automatically by the dependencies resolution here. So APT is capable to query those repositories, to work with the repositories, download the necessary software, and then pass it to dpkg, use a dpkg to install individual package, and APT is going to be smart enough even to, most of the time, figure out the order in which the package have to be installed if there are any constraints here. So again, APT get, APT cache, APT suite of tools is actually a set of command line tools. It's also a way to store packages on your machine, on your workstation. So it's all those things together. Okay, it's not just one piece of software. It's a suite of tools, and it's an organization of how to manage package on your workstation, pretty much. And this, because it's a command line tool and it's one small tool, I mean it's not small, but you know what I mean, it's an individual tool that is doing one thing and doing it well, that has allowed other people, and I'm going to erase this to make room, that has allowed other people to build on top of APT the same way that APT was built on top of dpkg. So what would you want to add to APT? Well, some people are allergic to command line, so maybe you want to add, for example, a cursor-based text interface, but that has menus and lists and things like that. So you can use your mouse, not your mouse, but your arrow keys to move from one package to another. It's kind of a windowed system in a text console, okay? So you can implement this aptitude. You can implement a full graphic user interface that's going to work on different desktop environments, okay, like Synaptic. Synaptic can rely on APT to actually do its job. And then you can go even further. You can implement a marketplace. So, for example, the Ubuntu marketplace. I think it's called the Ubuntu Software Center, if I'm not mistaken here. But this, again, you didn't have to implement everything by hand. You just need to have specific repositories. So each of those tools can actually work on their own repository if they wanted. They would be able to have a team maintain a repository. I don't see how that would be a good idea, but you could have a team completely duplicate the official Ubuntu repository, modify all the package for whatever reason, host them on their own server, and build a tool that's going to instruct APT to point to that repository instead of the official repositories, and download things from there, manage payments maybe, and things of that nature. So you can see how this is a very scalable architecture, okay? We have dpkg here, then the second generation is APT. I would say the third generation is Synaptic and Aptitude. Then the last generation, not because of a tremendous change in the technology, but more because of its application. The application being that you allow people to also buy software and buy videos and buy multimedia content, etc., would be the Ubuntu Software Center. So it shows you how. Well, it shows you two interesting things. Well, first, it's an introductory video, so it's really there to just give you the lay of the land, allow you to see, what is happening in terms of all the options available to you. Okay, so it gave you a list of tools. It gave you a list of software package managers, pretty much tools. It gave you a list of package format. It gave you a list of repositories. So it gave you an idea of what is the variety available there. Even more so than that, maybe the most important lesson to learn here is that of the Linux/Unix philosophy of design. Okay, dpkg is just a command line tool. Okay, why would you develop a graphical user interface that does package management. So this graphical user interface would do two things. It would do the graphical user interface part, and then it would do the package management, right? Why would you put this inside the same piece of code? As a matter of fact, when you develop something like that, don't you end up separating the code that does package management so that you can easily do, for example, unit testing on it? Okay. These are like the business logic, if you want to use this terminology. These are like core feature of your app. And then the graphical user interface is a different task altogether. I mean, the kind of programmers that can be very good at developing this part might not be good at developing this part, and vice versa. So your software project is going to separate those aspects. Okay. Well, in this case, the separation is even more, how to say, drastic, because dpkg represent, and I'm going to erase a little bit the scribbles here, dpkg represent what's happening here, the package manager. But instead of having dpkg, you know, being for example, a set of classes inside a larger project, dpkg is its own command line interface tool. And then you can develop 1 or 2 or 3 graphical user front ends. So that's a term that you're going to encounter a lot. Okay, and these are separate projects by separate team, by separate programmer. All they do is use the feature of dpkg, right? And then guess what? You can have another command line interface tool like apt use dpkg to provide more feature, and again you can have like front ends for apt, and then you can have, and so on and so forth. Okay, so this is the development philosophy of Linux Unix, and I think this is something that is still relevant even nowadays. Okay, it's something that you can apply actually to many different projects, given the fact that you're not completely allergic to command line, and you are capable to open that possibility for you to implement part of your features as command line tools that you can then leverage in your application at large. Okay, so to sum up, quick final diagram to sum up here. Let me clean up things. It's not going to be a big diagram. So we talked about users. Okay, users, system administrator working on their workstation. We talked about them having a software package manager, a piece of software, a unique piece of software managing all the installation on their system, pretty much. That software package manager was in contact with different servers. So this is going to be how I'm representing a server. Okay, different servers that host repositories for that specific distribution. Okay. The SPM was divided actually into several components. So we had what APT is, an advanced packaging tool, you know, something that is capable actually to manage dependencies, etc. And then we have the dpkg level, which is pretty much package management. So let's call this package individual package management, so manager, and packages, software packages, system manager, just to introduce a terminology to differentiate them. So you do understand that this is a tool working on a file, a deb file for example, and this is a tool managing the complete install of all packages on your system and managing the relation with the repository. One thing that I'm going to add to this overview diagram is, where are developers in all this? Well, let's say that developers are here. Okay, so the developers are the people that offer the software that you're using, and the developers are, for example, uploading to sourceforge.net, you know, the code, the source tree for their program. Okay, every time they implement a new feature, the source code goes on a publicly accessible server. Well, one thing that you might not be aware of is the difference between a developer and a package manager. So developer are people, users are people, package managers, lacking room here, maintainers, not manager. I've been using the word management too much in this lecture. So package maintainer, who are they? They are also people. They are people that are going to take the source for an application, for example Firefox, and they are going to generate the software package for Firefox on, for example, Ubuntu. So they are going to take a piece of software that is already developed by other people, by another team, and their responsibility is simply to take regularly the latest version, the latest release of that software, package it according to the deb or RPM format, adapt it to a specific Linux distribution, for example Debian versus Ubuntu, and maintain that package, that software package, so that it's available to download, to locate, download, and install from any repository. Okay, so that might seem like this might be something that you completely overlook until today, but this is actually an essential part of this community work, and this is something that has its own challenges, and this is something that has its own bugs. That's why sometimes you can have problems with the package, and these are going to be fixed by the package manager here, rather than the developers. The developers might not even be able to actually, might not even be knowledgeable maybe about the different format of package, the different version of package that are being maintained for them. The idea is that their software is useful, popular enough, so that people volunteer their time to package it for different distributions, and they manage those package independently of the developer. Now, sometimes the user reports a bug, so I'm going to illustrate this like that. The user finds a bug with a software, reports it actually to the package manager. The package manager either fixes it in the package if it's related to the package management, or passes it up to the developer, which is going to have to fix it because it's actually a bug in the application. And then obviously, you know, this flow goes back here. The new version of the software is released on the open source, for example, SourceForge site. The package maintainer is going to download this latest version, build it for the different architecture, package it, upload it to the repositories, and then it's going to be available via the software package manager to the user, who is going to install the next bug fix, the next security patch. Okay, I think this is enough for this overview of package management. So I'm going to leave it at it for now, and we'll have other videos that are going to build on this to go more into the specifics of the different tools that we have mentioned. Thank you for listening to this.